Hello and welcome back to Joe's Math Tools. In our session today, we are solving another rational equation by finding the LCD first. And if you want to see how this is done, let's get started. In solving our rational equation today, we will be using the denominators in our fraction to find our LCD. And for our fractions, we have 6 and k in the denominator. So my LCD will be made up of these two terms, which will be 6k. So now that I have my LCD, I'm now going to begin converting my fractions into their equivalent form where each one has a denominator of 6k. So let's begin with our first fraction, and we will be multiplying this to 6k. Now remember that with our LCD, we're going to begin crossing out our common terms, so my 6 can cancel, leaving us with just k. So k times k will equal to k squared. So for my first fraction, k squared will be its equivalent form. And now we're going to work on our second fraction, which is 5/6. And this would also be multiplied to our LCD of 6k. And just like we did before, we are going to cancel out the terms that are common. So we're going to cancel out our 6's again, leaving us with just k, and 5 times k, which equal to 5k. So now for our last fraction, I will be taking the minus sign along with my 1k, since that is the sign in front of my fraction. And we will be multiplying to 6k just like we did before. And we will be canceling our k's for this fraction. So our -1 times 6 will equal to -6. So now that we have converted our fraction into their equivalent form, we're now going to just focus on the numerator and solve our equation for our unknown variable k. And now since we have what looks like a quadratic equation, I will be switching all of my terms to the left hand side to set my fraction in its standard form for quadratic equation. Remember that the quadratic equation is our ax squared plus bx plus c, which is equal to 0. And remember that you could have done this on either side of the equation, so play to your strengths. If you don't want to deal with as much negatives, remember that in switching k squared to the right hand side, that will make k negative. So if you don't want to work with too much negatives, just switch it to the left hand side to where you would only have to be working with a -5k the way I did. Remember that either side, it doesn't matter as long as you work through the question correctly, you should still arrive at the same answer. So remember that for this video, we will be working with the factoring method. I will also load a video on the quadratic form where you can see how you can solve this equation using the quadratic formula. But remember that for this video series, for the rational equation series, we are using the factoring method. So now in factoring this question, I will be looking at my number 6, which is my constant. And looking at my number 6, I am also taking the -5k into consideration. So what that means is I'm looking for two ways that I can multiply to get 6. And we know there are two ways that I can multiply to get 6. Well, I'm looking for one way, that I can multiply to get 6. And I'm looking for, in multiplying to get 6, there are two things I need to consider. One is that in multiplying my numbers, I need to be able to get 6. And the second thing is that when I add or subtract these numbers that I multiply to get 6, I must also be able to get the -5 that's attached to my variable. So I need to be able to multiply to get a +6, and then when they are added or subtracted, I need to be able to get a -5. Now in this question, there's only way that I can possibly do that, because I know that with 6 times 1 I will get a +6. But if I was to make either one of these numbers negative, the 6 will also become negative, and as a result I can still get the negative 5. So for example, if I decide to use this method and I make the 1 negative, but actually I would have to make the 6 negative to make this more feasible for my question. So if I made the 6 negative, then I will have 1 times 6, but then I would have a negative 6 here. But then at the same time, if I was to have 1 minus 6, that will still give me my negative 5. So yes, that approach would work for one part of my question, but it would not work for the other part. So of course, I won't be able to use 1 and 6. So let's look at 2 times 3. Now to multiply 2 times 3, I can leave this as is, which will give me a positive 6. But if I was to add 2 plus 3, I would get a positive 5. And even if I was to make the 2 or the 3 negative, I would either get, for example, 2 minus 3 would give me a negative 1, or negative 2 plus 3 would give me a positive 1. So in this approach, 2 times 3 as is will not work out for me. But what I can also do is, if I was to make both the 2 negative and the 3 negative, that would give me a positive 6. And in using negative 2 minus 3, that would give me a negative 5. So with these two setup of the numbers, or with this particular setup of the number, this would work out to my advantage in factoring my equation. So I can use those two numbers. And what I'm going to do now is, I'm now going to factor in these two numbers into my question, where I'm going to split my 5k into these two numbers and then put in my 6 and still equal this to 0. And now I'm going to begin factoring my numbers by grouping. So in grouping, I'm going to be grouping these numbers in 2. So I'm going to group these two together, and then we'll work on the last two afterwards. So in my k squared minus 2k, I can factor out a k. And in factoring out a k from k squared, that will leave me with 1k, because k times k will give me k squared, which I will put back my negative 2, because k times negative 2 will equal to negative 2k. So this first part of my fraction is now factored. And now what I'm going to do next is I'm going to now factor the second half of my question. And in factoring this part, I can factor out a 3 from both of these. So I'm going to factor out actually negative 3, which will leave me with a positive k. And then in factoring out negative 3, remember I need to multiply 3 times, which is going to be 2, to get back a positive 6, and which in my 2 will need to be negative for that to happen. So you must keep in mind that in factoring that you have to get back the original form of your equation when these numbers are multiplied back to each other. So now that I've factored, and again another key point that you need to remember is that when factoring by grouping, these two fractions, these two parentheses, which is k minus 2, both of them has to be exactly the same. So they can't be two different parentheses, they must be exactly the same. So now that I have factored my two parts of my equation, I am now going to form my last parentheses to complete my grouping method, which will be form of my two parts outside of my parentheses, which is my k and my minus 3. And I will put back my final bracket, which is the k minus 2, and this is equal to 0. And remember that if you want to check this answer to see if this is factored correctly, remember in using your FOIL method, you should get back this original equation. If not this, but mostly this one you should get back, because this is the original equation that you started with. So when factoring, you must make sure that you get these fractions, these equations back, because that is what your two parentheses were factored from. And if you don't, that means you need to check your workings. Something is definitely off. So now that I've factored my equation, to solve this, that means that k minus 3 is either equal to 0, or k minus 2 is equal to 0, where k will be equal to either 3 or k will be equal to positive 2. Okay, so now that we have solved our equation, we've gotten our two answers for our quadratic equation. Let's begin by checking our solution, and we will start off with the first answer we got, which is k is equal to 3. And we're now going to replace 3 for k everywhere that it appears in our equation. I remember that we are working with fractions, and I love fractions because there are so many different ways that you can approach fractions to solve your questions. And I'm going to show you 2 ways that you can approach this fraction. And it's going to be very interesting, but I'm going to show you it in either way. And then I guess you can go from there deciding whether you want to use the method or not. So I'm going to begin by first finding the LCD. And we know that the LCD for 3 and 6 is, of course, 6. So let's convert our fractions to the equivalent form where 6 is in the denominator. And since my first fraction has 6 in the denominator, that will say the same. Same thing with my 5. And then in looking at my 1/3, I will need to multiply 3 times 2 to get 6. And then -1 times 2 will equal to -2. And now since we have our fraction in its equivalent form, let's focus on our numerators, where we will have 5 minus 2, which will equal to 3, and our equation is equal to 3 on both sides, which means that this is a valid answer for this equation. And now in looking at this fraction, there is of course another approach you could have taken. You could have used the grouping method, which seems a bit strange to say for fractions. But I'm going to show you what I mean by the grouping method. I'm going to group my fractions with their like denominators together. And of course, since 6 is added on the left, I'm going to subtract that on the right, leaving my -1/3. And I'm going to work out these two fractions, and 3 minus 5 will equal to -2/6, which is equal to 1/3. And in looking at these two fractions, we know that we have an equivalent fraction in the play here. And what I'm going to do is I will be dividing my fraction. To be dividing this by 2, and I will divide my denominator as well by 2. And -2 divided by 2 will equal to -1. Still didn't. Okay, so it's in now. And 6 divided by 2 will be equal to 3. And we see that we have -1/3 for both sides of the equation. Again, remember this is equivalent fraction. So you could have decided to reduce this fraction by 2. Or you could have decided that on the right hand side you wanted to multiply them by 2, which would have given you the right hand side of the equation. So either way you decided to approach it, you would have still been able to get an equivalent answer on both sides of the equation. So this is just one of the great things about fractions and how you can approach solving these type of questions. And now let's check our last and final answer, where our k was equal to 2. And again, we're applying our substitution and substituting 2 for k everywhere that it does appear in our equation. And now I showed you 2 different methods you could have used to approach checking your answer here. And of course, I'm going to stick with my classic, which is finding my LCD, which would be for 6. And now we are going to convert our fractions into the equivalent form. So 2 already has a denominator of 6. 5 also already has a denominator of 6, and I will be multiplying my -1/2 times 3, because 2 times 3 would give me 6, and 1 times -3 would give me -3. And now we're going to focus on solving our numerator, where we have 2 is equal to 5 minus 3, and our 2 will be equal to 2, which means again that our k minus 2 also solves for a valid answer for our equation. Okay, so there you have it. We just solved the quadratic equation by using the LCD and by applying our steps for substitution. We even did some factoring in this question as well. But remember that in solving these type of equations, especially our rational equation, it tests so many of your skills as relates to algebra, and in this case, even some of your foundational skills as relates to fractions. So make sure that when you are approaching these type of questions, you keep your basic foundations in mind as you work through these steps. But the best thing that you can always do is to get some additional practice in. Get them right, get them wrong, but make sure that you are practicing to develop your skills daily. And when you're ready to learn a new skill, make sure that you return back to Jules Math Tools, where we make math easy.